I'm with Acana, and I love APIs, as we all do at Acana, and I think for most of you who have been probably present yesterday and this morning, it's probably clear why we do that, because APIs help us to effectively deal with some of the disruptive factors that we are seeing in these days. I suppose most of that stuff is already familiar to you now, so I won't linger too long on it. But just to point at a few things here, some disruption that is causing ripples in the banking world is the availability of mobile devices, and it's not the mobile devices as such, but it's what these mobile devices allow us customers to do, which is basically demand services whenever we want them, at any time we want them. And talking about customers, I think that's another thing to consider here, is that customers are not something that we can easily take for granted anymore. I mean, there used to be a time when, and some of you can probably also remember that, when I actually had to walk into a banking building if I wanted to do something with that bank, and nowadays I don't have to do that anymore, which means that, you know, the customer is becoming kind of an anonymous entity to banks, and banks will need to have their focus on customers more and more in order to kind of retain them. So that's all lovely, and I think we all agree that this disruption is being addressed by APIs, and that's all very nice. But there is a dark side to that as well. And since this workshop is about security, I think you start getting you know what I'm getting at, and that is the risks associated with APIs. So even though we like them, we also have to be very conscious of the risks associated with them. Risks basically come in two ways, you might say. On the one hand, there's regulations that will introduce some risk. I mean, we can open up our services, we can create APIs, and then suddenly the government may come up with some additional regulations. I mean, PSD2 has been mentioned, Access to A has been mentioned, that force us to change the API or to provide additional features on top of that API. And we may not have taken that into consideration. So does that mean that we actually have to go through all of our APIs and apply those changes? That can be tricky. And even darker, of course, is the possibility that we have seen yesterday of possible hacks on the APIs. So the more we open up our stuff, the more we need to be conscious of the possibility that there's also people that may want to do things with it that we wouldn't really approve of. And this is a reality, as we all know. And it's here with us, and these are just a few examples of things that have actually happened in recent times. So I think people are getting more and more creative in getting access to the stuff that we are happy to open up, and it pays off very well, as you can see. So having said all that, we have to address the question, how can we securely open up our functionality to the wider world? And that obviously is where Acana comes in, and I think I hand over the microphone to my colleague now.
Thank you. Thank you, Olaf. So let me take a step back. I mean, obviously, we are all here. We all love APIs. And we want to expose APIs, we want developers to adopt APIs, but we want to do so in a secure fashion. So before I jump into like what are the different aspects of API security, what are the challenges, and what do you need to do it, let me just take a step back and kind of go in and talk about the evolution of digital channels and go back to like maybe late 90s and see how information system and software and the technologies behind that have evolved over the last couple of years, or maybe the last decade, and where we stand today with APIs and how do we secure APIs. So if you look back, maybe early 90s or late 90s, that's when the era of client server. Client server was huge. That's when I graduated from college, and the first thing that I wanted to work on was client server. That was cool at that point in time. That was great technology at that point in time. But if you look at connectivity in those days in client-server, was essentially you had back-end servers and systems. Everything, essentially client-server meant everything, your programmable logic, your data, everything was essentially in a database or some data store or maybe some servers. And then there was a dumb client. And connectivity between the client and your servers was essentially achieved through limited access. It was your data was not usually accessible outside the perimeter of your firewall. It was all whoever inside through network connectivity, through network isolation. It was achieved, security was achieved through network isolation. Very few people were given those dumb terminals. Okay, you have access, you can log in and you can connect. And very, very few people could go outside the firewall and access that. Good enough, worked in those days. And then came in web services or SOAP or service-oriented access protocol. And that really, really opened stuff in early 2000. And external connectivity and B2B connectivity, a lot of B2B connectivity was powered by web services and SOAP. And actually security was pretty good with SOAP. I mean, I don't think security was bad, but it was extremely, extremely complex. In order, you had WS policy, WS trust, WS security. There was a bunch of extremely, extremely complex standards in there. And the session before me, you kind of went into quite some detail as to how complex it was. And absolutely, it was. You had to be a rocket scientist in order to implement WS security or SOAP security. But it was secure. It was quite secure if you could get it. And then over the last couple of years, essentially with APIs, and essentially APIs have been driven by making things available across various different channels. So one of the main drivers behind why APIs have been so successful is because it's easy. It's extremely easy to consume APIs. It's extremely easy to develop APIs. You self-provision APIs, or your developers self-provision APIs and start using them. And with that in mind, obviously, APIs have been extremely powerful and make access to data and information available everywhere. But how do you make them secure? How do you make them secure in the sense that the data that's leaving outside your bank remains still secure? And that's where API security comes in. And these are the different aspects if you look at what are the things that you need to secure. So obviously, if you go right on the right side, you need to secure your backend. You need to secure your data. You need to secure your servers. You need to do applications. You need to secure your backend, whether it's on premises or on the cloud. You need to secure that. You need to secure the channel. You need to secure the communication channel, which is encrypt that channel, prevent man-in-the-middle attack, secure that channel. Then, as you are exposing APIs through this secure channel, you still need to make it easy for developers to access your APIs, to test those APIs and develop apps against them. So you need to make that. And once they develop the mobile apps, you need to make sure that the user experience, the end user experience is really, really easy. That your applications need to be secure, but it should not show up in the user experience being really, really difficult. They have to type in a lot of stuff, RSA, token IDs and things like that. It needs to be really, really easy. And at the same time, make sure that you are securing not only the app or access to the app, but the data. If the app is storing some data or you're entering some data, that's secure data like social security number, credit card numbers, or personally identifying information, that remains secure. Not only through the entire channel when it goes to the backend or it's accessing, but also when it's storing it locally on the app. So there are a lot of security solutions. If you look at the landscape, why do you need specifically an API security solution? Why not the existing solutions look at it? And this is a very high level, a very rudimentary look at the security landscape. But if you look at the security landscape, there I've divided it into 3 or 4 spaces. The first one is single sign-on. So there's obviously a lot of single sign-on solutions, but single sign-on solutions are essentially meant for authentication and authorization of the resources that you are trying to access. So that still is valid, but so that's one single sign-on. There are a bunch of vendors in there. Then just from a mobile applications perspective, endpoint security perspective, there are a lot of mobile security solutions like MobileIron, Good, AirWatch, and others in the space. It's a very crowded space. I've just put a few vendors in each bucket. But that's more about endpoint security for mobile devices and only for enterprise apps. They are not valid for consumer apps because you need to license them. Consumers don't buy those kinds of NDM solutions. They don't protect those. Over here, actually, this is a very, very big space, but there's all kinds of firewall, perimeter securities, there's advanced threat protection, big data, machine learning, everything going in there, bunch of vendors in there. But if you look at all those 3 buckets, they are not really looking into API-specific threats, which are protocol-specific, specific to XML or JSON. There's something around key management I'm going to talk about. A lot of you might already know about it, but APIs, the way you license your APIs, the keys associated with this OAuth licensing, security tokens. So there's a bunch of things that are very, very specific to APIs that you need to start looking into. So we recently did an API security survey. So we sent request to maybe around 1,000 CSOs of large enterprises and asked them what were their major concerns when it came around API security. Were there any concerns around API security? And these are kind of the things, and you can go to our website and download this report. It's a very recent report, came out maybe 1 or 2 months ago. There are a lot of concerns. I mean, if you look at XML bomb, JSON schema, DDoS, XML firewall, cross-site scripting, I'm going to talk about each one of these. These came out, and you can go and look at in the report. But the most interesting thing that came out of the report and actually took us as a surprise, and most API vendors today don't kind of offer something like this, is once you access the API, or once a developer accesses the API, your backend can be secure. Your API can be secure. But are you taking any steps to make the API consumer or the API app or the mobile app, the API consumer app, to be secure? And by what that means is, once, like the PII or the PHI information that I was saying, this data at rest, if the app is accessing social security number or credit card information, and if it is caching it locally on the app, what processes are you taking into account to make sure that that data is stored, encrypted, and it's not available for hack, which is endpoint app security. And those things actually fall in a gray area. Most API vendor security and things that I'm going to be talking about don't address it. So we'll come about it. It's an interesting discussion. We have some solutions around it, or I have some thoughts around it. We can talk about it. But coming into the various things, I mean, the basic steps of securing an API. What are the basic steps of securing an API? If you look at this example, on the right is your backend repositories, data sources, or applications. You're exposing them as APIs, maybe through the cloud or on-premises system. There's a mobile device or app or any IoT device that's accessing. That's where the app resides. And the user, the end user that's accessing that mobile app. So the various steps in the entire life cycle of API for securing is, first is authentication and authorization. So you need to authenticate and authorize the user. Even before that, actually, is once the API is available on your API portal, you need to authenticate and authorize and license access to that API to the app developer. And that's a very, very important step. I mean, I think in the entire API security, this is the most important aspect of securing the API, which is the API key validation, the API key licensing for the app developer that's accessing your API. Message security, which is securing the channel. Threat protection, I'll go into details into each one of these steps. So threat protection, which is if somebody gets access to your API or trying to get access to API, what all things that he can do in order to kind of hack your API. Content filtering, again, kind of related to threat protection, but it's more about what's coming, what kind of data that's actually coming through your API and how do you validate that data. And these are essentially those 5 steps, and rate limiting is the 6th step. So these are 6 basic stuff that you should essentially be taking into account in terms of securing an API. And none of this is negotiable in the sense that I'm doing 1 and 3 and 4. Is that enough? No. If you're not doing any one of them, your API is vulnerable. So you have to essentially do all the 6 steps. These are basic steps in API security. If you are not taking into account any one of them, your API is vulnerable and it'll get attacked. It will get hacked. There's a lot more that you could do, but these 6 are essentially those basic steps that you essentially have to take to secure your APIs. So let me go through each one of them very quickly. So the first is authentication and authorization. This is end user authentication and authorization of the user that's accessing the app through the API. So it's essentially making sure the user that's coming is authenticated and authorized in order to access the data there. So there are multiple standards over here in terms of authentication and authorization. OAuth is the most popular one. Essentially, most people are now using either OAuth or OpenID Connect. There are other standards, SAML, there are a bunch of standards over here in terms of what you can do. And usually, what's happening is authentication and authorization is going against either a standard identity and access management system, which could be provided by one of your vendors, maybe Oracle, maybe IBM. They're cloud vendors, Okta, and others that are coming into the space, or you might be using Microsoft Active Directory or any other LDAP server. So those are primarily the most common ones against which you do authentication and authorization. In some cases, you might also be going and doing against social channels, but I don't think so that's prevalent in the banking industry. You will not want a customer coming in and giving his LinkedIn ID to access a bank account or something. There might be some fringe cases, but I don't think that's the case. But in general, that's there. So very important kind of basic step, again, in terms of authentication authorization. But OAuth is the most popular standard over here in terms of authentication authorization. And just to explain a little bit about OAuth, again, a lot of you might know about OAuth, but for those who don't, it's very, very interesting what OAuth does. It essentially, at a very basic level, what OAuth is doing is it lets a person delegate constrained access from one app to another. So what does that mean is this is the resource owner. This is the user who's accessing, who essentially owns the account or the bank account or something. That's where the resource server is. That's where the bank account and that's where the bank data essentially sits. That's the end server where the user accesses the resource from. What OAuth allows is, it allows this user to give access to another app or a client app or a mobile app and say that it can go and access, this client app can go and access data from the end server on my behalf and get some information and display that information or process that information. But there is scopes in the sense that it defines only this data or this kind of operations can be done by that app. And the username and password and credentials are never shared with that app. The username and password are directly shared with the resource server. The resource server gives a token to the client app. So the client app never comes to know about the username and password, which makes OAuth an extremely, extremely secure standard from that perspective, which is the client app never comes to know about your username and password, and it's a restricted access to the resource depending upon what the user grants to him. So let's just take a very, very simple example. I like to kind of run through it. So this is a very common example. A lot of people in marketing use this as a social media management tool, Hootsuite. when you go into Hootsuite, they give you an option about, okay, can you sign in? You can sign in through Twitter, Facebook, Google, or you can use any other account. Once you choose any one of those, in this case, I think I choose, what do I choose? I choose Twitter. So when you choose Twitter, it displays me authentication screen. This screen is not Hootsuite. It's going directly to Twitter. This is Twitter. This is not Hootsuite. It's redirected me to Twitter, wherein I need to give my username and password or any other kind of, it's two-factor authentication. I can provide that. And it also provides me the scopes, which is the permissions that the app is requesting for. And you can define these scopes, and a lot of places these scopes can be configurable, check box and things like that. But these are essentially the things that Hootsuite is requesting from me. And once you authorize this access, you can go in and you can start. So Hootsuite never gets your credentials. It's just getting an access token or a bearer token on your behalf, which again you can put timestamps on it and when it goes. So it's an extremely secure way. It's a very usable way of doing it because you don't have to access or bearer tokens have timeouts associated with it. So if somebody's accessing from a mobile device, you don't need to keep on going and entering your username and password. Very, very secure, but it's extremely complex to implement it also. It's extremely complex. There are two aspects to a OAuth flow. There's the OAuth client. The client is the app where the app needs to kind of take into account provisioning and the approval flow, which is when the first time the user logs in, what's the approval flow? There could be a 3-legged, 2-legged. OAuth has a lot of different versions and different ways in which you can configure your authentication schemes. And then there's a OAuth server, which sites on the back end, which decides exactly where the resource server is. And that needs to take care of identity integration, which is integration with your authentication and authorization system. It needs to do token validation, which is once access token or OAuth token is issued to a OAuth client, it needs to, every time a request comes in, it needs to do token validation and token issue and refresh if required. And bunch of other stuff. It's extremely complicated to code this. And there are a lot of solutions in the market. Actually, Mehdi, who organizes API Days, he has a company around it called OAuth.io that simplifies stuff. Most API vendors like us have some solutions around it. But it is complicated stuff. After authentication authorization, there's the next step that's called licensing. So when you create an API and make an API available to your developers, don't ever make a universal license available to them. When you issue an API key to a developer, you associate a license, and the license has two things. One is there's the business license, and the license can say, okay, you can access these many APIs, and the license can also define the kind of resources that the developer is able to access, what operations the developer can access, how many times a day he can access. So define various levels of authorization scopes, document visibility, quota policies, and associate them with license. And that's a very, very, very important aspect of API security, not only from a business perspective, from a technical security aspect also, because it limits the type of access your developers have on your API. Make sure you always do that. I'll talk about some hacks, a lot of hacks. You have a question?
Question about how to actually store the API keys securely, because
I'm coming to it. Yeah. I'm coming to it. Absolutely, absolutely. I'm coming to it. It's a very good question. So licensing is one. I'll come to your question. Actually, the next one is absolutely over there. Then once you have done the license, you've taken care of the licensing and API key. Now it's the exchange of what's happening is the API key or the entire message that you have put in the API, and that's going back and forth between the app and your backend through the API. And what needs to happen is this entire communication needs to be secure. So implement HTTPS, and by the way, make sure you implement TLS and not SSL, SSL 2.0, 3.0, then they're no longer secure. I hope all of you are aware. How many of you were aware that SSL 3.0 is no longer secure? Most of you are, yeah. It's SSL 3.0 is no longer secure, neither is 2.0. So make sure you do implement HTTPS, but make sure that you have taken care of the right protocol over there or the right standard over there. In terms of parameters, if you're passing in anything through HTTP parameters, make sure, and API keys, coming back to what you were asking, API keys are essentially passed through the header, HTTP parameter. Make sure they're obfuscated, and they're obfuscated using the right parameters, usually HMAC. If you take care of passing them through HMAC-based authentication schemes, they're usually very, very, very secure. Yep.
Yeah, my question is also because today, when you build apps, it's normally put in App Store.
Yeah.
It's publicly available for everybody to get. So if you put the app key in the app, everybody can steal it. Or if you take single-page apps.
You have to encrypt it and keep it in the app. You cannot, I mean, anything that you store in the app, make sure that it's encrypted. Even the data that is stored in the app, even once not only your message key, which was your app key or license key or API key, but like I was talking about earlier, the data that your app is caching, which could be customer data, that also needs to be encrypted. Nothing, I think in this current world, and the speaker before me was also saying, nothing can stay unencrypted, and encryption is not expensive.
So where is this, to perform an encryption, you need to store the key. Where would you recommend to store the key?
So you can store the key, and along with nonce, which is time-based stamps, everything can be very, very secure. It's a separate topic when we can go into just the encryption thing. I don't want to go into details over there. But it's a public key and a private key. So they're usually asymmetric key encryption that you do. So what you do is when you encrypt and what other people have, you have one key stored on your app, and you are essentially storing it in a secure location. Apple, iOS, and all these things, they have now hard vaults on, like Apple Payment. So if you look at what Apple does with Apple Payments, or your fingerprint, like the store fingerprint, it all goes into a secure vault, and there's no API access to those things. Nobody has access to it. So there are a lot of secure ways of storing your keys and things. Yep.
I think that was kind of, I think that's another point, but the license key specifically, I see the case when you had kind of old school server-based applications that then could basically have a back channel to access to the APIs.
Yeah.
But when you're having kind of modern applications where you have, I don't think API keys makes much sense because you can't store them securely. I don't see how you can actually do that.
You can. We will talk about it. I mean, even if you look at this HTTP, your credit cards, they have a small chip on it that's encrypting your credit card number now.
Yeah, but if the application is being downloaded from the App Store, then I'm not requiring the user to kind of install the license key. The license comes with the app. You want to restrict a specific app to the API. I guess that's the typical problem we have.
Okay, let's take that discussion a little offline. I want to cover all the different things, and I'll come back to that. I mean, it's an interesting discussion, but I think your API key can definitely be encrypted, and it doesn't need to, whether it's the App Store or anything. I mean, I have I've talked to a lot of vendors. So there's this one vendor that's making parking meters all across San Francisco. And one of the initial challenges that they had is my parking meters are accessing, and anybody can go and hack my parking meter and get the API key from there. All of that can be secured, but we'll get into details. It depends upon what specific use case, how you're doing it, but all of that can be done.
Just on that,
Yeah. I didn't hear a lot. JWT. So JWT is another aspect. Yep. You can use JSON Web Token And there's a lot of ways of securing it, and depending upon what you're using, there are. But it's a complete different topic that we'll get into it later. The other aspects of API security that you need to take care of it, and some of these are very kind of familiar with web application firewalls and what web application firewalls do, is denial of service. Let me go back to one thing over here. So API key security is, I'm not trying to kind of say that it's not important. It's very, very important. Going back to 2013, late 2013, how many of you know about the Snapchat API hack? One or two, no. So Snapchat API got hacked, I think 60 million username, contact addresses, phone numbers, and everything got hacked through Snapchat over the holiday period in 2013. And essentially what had happened was the hacker got access to the API key. It was not obfuscated. The app was not obfuscating the API key. It was essentially clear. So it was going, the hacker got access to the API key, went back into the Snapchat hack, programmatically, in a very small period of time, made a lot of calls to the backend and got, I think the number is 60 million username and things, and got that. So there are two very, very important things that they were not doing. Obviously not obfuscating the API key properly and how storing it. We'll get back to it later if we have time. And the other thing is, on the backend, they had not implemented API licensing and rate limiting in the proper way. And we'll talk about it. Even if the API key was hacked, had they implemented API licensing and rate limiting, they would have been able to kind of they would have been able to prevent the hack much faster than and much less damage than 60 million records. Threat protection is another way people try to get in. Denial of service. They might attack your server by sending a lot of requests. Typical web injection, SQL query injection, and in case of APIs, it could be JavaScript or JSON. JavaScript, XPath query, XQuery injection text if you have XML. Cross-site scripting. Again, network address and range, blacklist, whitelist, you still need to take care of all of these. And HTTP parameter stuffing, which is also very, very popular both in the web world and API. Hackers will try all of these things, and you need to make sure. And a lot of web application firewalls take care of at least most of them. May not be the XPath and XQuery injection attacks, which are very, very specific to JSON and XML payback. Content filtering is the next thing that you need to take care of. Provide content firewalls, which is essentially look at your JSON payload or XML payload and make sure that the schema, whatever the schema is defined in the API, the message that's coming in is exactly with that same schema. A lot of hackers, they do what's known as fuzzing. They get access to your API key, and they will try to break the API. They will slowly change the schema. They will add more parameters. They'll try HTTP parameter stuffing. What they're just doing is fuzzing. They're hitting your API constantly with different parameters and different contents and different things, trying to break your API or the server backend. And as soon as they know that your server is not handling one specific case, that's their way to get in. So there's viruses that can be embedded inside your XML payload or JSON payload, so make sure that you're scanning. A lot of these are expensive operations, and again, depending upon how much throughput that you want to push through your API, you might want to put some checks and balances over here. And rate limiting, like I said, you need to associate rate limiting with your APIs, which is every license has some rate limiting policy associated with that. And rate limiting is how many times a day can a developer or an API make an operation request. It could be 1,000 times a day or 10,000 times a day or 1,000,000 times a day. You can have all kind of context in your policies, which is if they're making a call from a specific geolocation, from what type of operation are they making, what time of the day, you can add all those kind of context and segmentation. The more you do, the more protected you are. But make sure that you do rate limiting. The other thing which is very, very important specifically to credit card and finance industry is PCI compliance or other regulatory compliances that you might have, which is your entire infrastructure, like for anything that you do. Make sure that the entire infrastructure or the API chain and the components that are responsible for processing your APIs right from the client to the server to anything in the middle are not storing anything that is important. So if it's credit card information, if it's SSN, if it's anything else, make sure that everything is redacted or encrypted. Your audit and logs, it's not going in anywhere in audits or logs. So make sure that the entire infrastructure is taking care of those things. It's not only, so this is a common practice. Just make sure your API infrastructure is not an exception. So there are things like API gateway. A lot of it's a common infrastructure piece. Like make sure at least like a API gateway offers a lot of these things. I'll not go into most of it, but a lot of our customers are banking customers. So essentially, I mean, those are the 6 steps. Those are very, very basic 6 steps that you need to take care of securing your APIs. Make sure you're doing that. One thing I think that I wanted to talk about is, based on the survey, what came out is the app itself, the mobile app itself. How do you ensure, as an API provider, as a bank, when you expose your API, you might have an API gateway, you might have a web application firewall, you might have everything. But once you provide an API to the app, how do you ensure that the app is taking all the steps in order to protecting that data that's either that the app is capturing, the app could be capturing credit card information, sending it to you in an encrypted fashion, and you might be storing it and doing everything that's required. But what if the app is caching the credit card information locally and they're not encrypting it? Or the other way around, they're accessing some PII information or sensitive information and then caching it locally on the app. How do you prevent those things from happening? And I think that's where it's a gray area right now. It's a gray area in terms of most API security vendors or like API gateways. They don't handle the app security, or how do you manage how the app is developed. There are some things around API lifecycle. Coming from a legacy of SOA governance, we were known as SOA software. I think what you can do, and one of our largest customers in the US is a bank. What they did was they added an additional step wherein in the entire API provisioning lifecycle, obviously a developer comes in, accesses an API key, creates a sandbox. So every step they had an approval, and they added another approval step, which is finally when the app went production or in the app store, they added another review cycle wherein right before the app went to the app store, they have added another check where they go and code review the app itself. But again, it's not completely foolproof, because if the next version of the app comes in, how do you make sure that that is getting reviewed or they are not overstepping? But that's a gray area. I think as banks, you guys would have to make sure that at least you are aware of the app security. I think that will become pretty critical. So I think that's all I had. You can actually go to our website on resource.akana.com and find a lot of other stuff on API security and other resources. But I think the 6 steps that I mentioned over here are critical to API security. You should not overlook any one of them.
Okay, thanks, Sachin and Olaf. We'll give a quick applause now.